Hey guys, quick question you might have wondered before. How do premium EVs stay super light without sacrificing safety at all? It's not just better materials, honestly. A huge part of it lies in fully unmanned robotic production and ultra-precision intelligent manufacturing. This entire dark factory you're seeing right now? That's the real game changer, and it's exactly the core tech showcased at this year's AHTE and AMTS Intelligent Manufacturing exhibitions. Last video, we covered the full supply chain overview. But today, we're diving straight into the exclusive factory floor footage captured from the exhibition site. We're breaking down the flagship tech across 4 major exhibition themes: end-to-end robot-driven automated assembly, zero human intervention precision welding and composite connection, large-scale integrated gigacasting technology, and AI-powered digital closed-loop inspection systems. All the core solutions that make ultra-light, ultra-safe EV structural parts possible. If you love cutting-edge automotive smart manufacturing, full-process robotic workshop scenarios, and the latest industrial unmanned production upgrades displayed at top-tier auto tech exhibitions, this episode is definitely for you. Honestly, old-school car factories look totally outdated next to today's new generation EV unmanned workshops highlighted by AHTE and AMTS. Traditional production lines rely on heavy manual intervention for part handling, welding assistance, dimensional calibration, and repeated assembly, with low automation and inconsistent output quality. But the premium EV lightweight production system we're showcasing today? It runs on near 100% unmanned dark factory operation, the typical implementation of new quality productivity in automotive manufacturing. Every core process is fully autonomous, handled by intelligent industrial robots, and fully automated customized production equipment. Modern EV thin-walled alloy lightweight components demand extreme machining precision and rock-solid batch consistency limitations that manual operation can never overcome at scale. Only continuous, stable, robot-driven closed-loop intelligent production can meet the ultra-strict lightweight optimization and vehicle-grade safety standards for high-end electric vehicles, which is the core upgrade direction of current automotive intelligent manufacturing. First up, let's focus on the core highlight of AHTE's Robot and Assembly Exhibition Zone, the fully automated 6-axis robotic welding and flexible assembly cells. What you're seeing here is complete zero human operation throughout the entire welding and assembly cycle, a standard flagship solution for modern auto body intelligent production lines. These high-precision industrial robots integrate advanced drive control systems and multi-sensor fusion modules, achieving an ultra-high repeat positioning accuracy of plus or minus 0.03 millimeter, far tighter than conventional traditional automotive robots. Every weld path planning, every precision part alignment, every microscopic dimensional micro-adjustment is fully calculated and executed autonomously by the robot system. Paired with real-time laser vision positioning and infrared thermal dynamic sensing technology, these robots track weld seams in real time, tweak welding process parameters on the fly, and flag microscopic welding defects instantly, all completed automatically without any human supervision or auxiliary intervention. This professional robotic fleet is purpose-built for high-difficulty thin-walled alloy lightweight components widely used in new energy vehicles, aluminum body panels, lightweight magnesium alloy chassis parts, and ultra-thin battery structure frames. These new lightweight materials are highly heat-sensitive and extremely prone to thermal warping, welding deformation, and crack defects. Exactly the bottleneck that traditional human-assisted welding processes cannot solve stably. Instead, these intelligent robots apply millisecond-level dynamic heat input precise control technology, independently adjusting welding current, voltage, and scanning speed in real time to effectively suppress thermal deformation of thin-walled parts. Beyond precision welding, the footage fully presents the complete unmanned intelligent logistics and flexible assembly workflow advocated by AHTE. Robotic arms undertake automatic raw material picking, precise positioning, and component fitting, while coordinating with intelligent AGV handling robots to realize fully autonomous cross-station material transfer and line body circulation. The industrial upgrade effect is remarkable. 50% shorter production cycles, 0 manual assembly errors, and 30% higher structural strength of welding joints for every lightweight component. Next, let's dive into the core spotlight of AMTS Future Automotive Technology Exhibition Zone. The dedicated fully automatic integrated die casting and precision post-processing lines for EV lightweight parts. Traditional auto component workshops rely heavily on manual monitoring of molding processes, manual deburring and manual sampling inspection, resulting in unstable product precision and inconsistent batch quality. But this advanced intelligent production line is a true 24/7 Stark factory. No on-site operating staff, no manual process intervention, achieving full automatic continuous production, representing the leading level of automotive gigacasting intelligent manufacturing. The line is professionally engineered for core EV lightweight components, aluminum alloy battery trays, integrated vehicle body floors, lightweight door frame structures, and electric drive housings. It covers the full process intelligent manufacturing solution showcased at the exhibition. Unmanned high-pressure vacuum die casting, automatic mold constant temperature control, intelligent robotic deburring, high-precision CNC micro-machining, and automated structural stress relief treatment. The biggest visual and technical centerpiece is the large tonnage robotic integrated gigacasting system running autonomously. The start technology of AMTS lightweight manufacturing, a 9,000+ ton ultra-high pressure die casting unit, paired with intelligent mold real-time monitoring robots, consolidates more than 50 scattered discrete parts into a single integrated large component in one automatic molding shot. This breakthrough alone eliminates over 40 traditional manual assembly and secondary processing steps, completely removing assembly gaps and quality inconsistencies caused by human operation. During the die casting molding stage, real-time pressure and temperature closed-loop control systems automatically adjust mold filling speed and solidification parameters, effectively preventing common defects such as part warping, shrinkage cavities, and dimensional drift. After molding, automated deburring stations and 5-axis linkage CNC finishing robots conduct ultra-precision secondary processing, strictly holding machining tolerance within plus or minus 0.01 millimeter. Every fitting surface, every mounting hole, and every critical structural dimension is precisely refined and calibrated by intelligent equipment alone, ensuring ultra-high consistency and ultra-high precision of lightweight parts in every production batch. Beyond welding and integral molding, our exhibition footage also captures the cutting-edge unmanned composite connection process in a HTE connection technology exhibition area, fully automatic robotic riveting, and intelligent structural adhesive bonding systems. Unlike legacy workshop modes that rely on manual rivet gun operation and artificial glue coating, this EV lightweight manufacturing zone adopts fully autonomous robot hybrid joining technology, a key promotion solution for new energy vehicle body connection. High-precision spar self-piercing riveting robots, equipped with real-time pressure and displacement sensing modules, dynamically monitor the force curve of each riveting point, precisely controlling rivet expansion within 0.05 millimeter accuracy with full automatic operation. Meanwhile, intelligent precise dispensing robots apply uniform high-toughness epoxy structural adhesive with quantitative fixed-point control. This innovative robotic riveting plus automatic structural bonding dual connection process builds high-strength integrated joints with zero human involvement, perfectly balancing vehicle lightweight design, body structural rigidity, and excellent NVH performance. Now, the final stop on our Unmanned Smart Factory tour is the AI-driven full automatic quality control system, a key digital manufacturing theme jointly promoted by HTE and AMTS. In traditional automobile manufacturing plants, quality inspection relies heavily on human visual observation and manual sampling, making it easy to miss tiny microscopic defects. But this EV safety component production line realizes 100% full coverage inspection of all parts, with zero manual participation, achieving full process quality traceability. You're watching a full suite of intelligent automated inspection systems running non-stop. 3D laser scanning robots, high-precision microscopic defect detectors, automatic dimension calibrators, and ultrasonic non-destructive testing devices, all operating autonomously to complete full-dimensional quality verification. These intelligent inspection robots capture complete 3D dimensional data of every finished part in seconds, matching and verifying with digital twin reference models to identify microscopic dimensional deviations and subtle surface flaws invisible to the human eye. Ultrasonic testing equipment automatically scans the internal structure of components to detect hidden micro cracks and internal void defects caused by die casting and welding processes. All inspection data is uploaded to the industrial platform in real time. The system automatically feeds back error data and optimization instructions to upstream production robots, realizing autonomous equipment self-calibration and process parameter iterative optimization. This complete unmanned production inspection closed-loop architecture ensures every lightweight component fully meets global top-tier automotive safety and quality standards. To wrap up, what we've demonstrated from this exhibition is a full-set, robot-centric unmanned smart factory solution tailored for EV lightweight manufacturing, covering all core hot topics of AHTE and AMTS 2026. From intelligent robotic welding and flexible unmanned assembly, to large tonnage integrated gigacasting and advanced composite connection technology, all the way to AI machine vision inspection and digital twin closed-loop optimization. The entire workflow is machine-driven, zero human intervention, and high-precision standardized. This mature, fully robotic intelligent manufacturing ecosystem is exactly why modern premium EVs can achieve extreme lightweight optimization while delivering class-leading structural safety and long-term operational reliability. All right, that's all the core downstream intelligent manufacturing tech we unpacked from this AHTE and AMTS exhibition today. Next video, we're going back to the material fundamentals of EV lightweight manufacturing. We'll break down the unique physical properties, processing characteristics, and irreplaceable industrial value of aluminum alloy, magnesium alloy, and copper in new energy vehicles, and explain why these three core metals have become the cornerstone of modern EV lightweight upgrading. You won't want to miss that in-depth material tech deep dive.